Good afternoon. My name is Alwani Al-Gaddafi and I am from Libya. I am a research student at the Munich University. I will talk today about comparing the impact of off-grid system and on-grid system on realistic load. Let's move now to my outline of my presentation today. I will talk about, give the introduction for my presentation, and will present as well the aim and objective of my paper, and also will describe the system description, and actually will describe the Sunny Island schematic diagram and how the experimental setup has been done, and we will see the off-grid and on-grid system, and also will analyze the experimental result. Finally, we will give the conclusion and the future work. Renewable energy is very important nowadays because it can come over the problem of environmental problem and also can get electricity, security of electricity, and also we can supply the rural area. The solar energy, it has some challenges such as reliability of power electronic and efficiency, and also the interaction between the grid. Also the renewable energy, especially the solar energy, it has problem of intermittence, which is a change during the day. So the IC mini-grid system needed to be tested and see the impact of those variation. Also, I will compare as well between the off-grid system and on-grid system in terms of power quality and how power quality can be achieved between both configurations. Let's move now to project aim and objective. The aim of this paper is to describe the IC mini-grid system and how to integrate the IC mini-grid system with different resource energy. Also, how to provide management of power flow between the generation and consumer. In order to improve the power quality, the optimal design of solar system, optimal design of the control of solar system is needed to improve reliability as well. The main objective of this paper is to developing IC mini-grid system to get more power quality and also to improve the power quality of available inverter. Also, this is a system we need how to implement in the future in Libya. In a framework of the IC mini-grid system, we will develop firstly how to design a frame for maintaining the different elements of IC mini-grid system. Also, how to test the IC mini-grid system with different equipment such as oscilloscope and power analyzer, and we will see also the limitation of the IC mini-grid system. Also, we will see how to improve the power quality of proposed IC mini-grid system. This is what I am going to do in this paper. Let us move now and describe the IC mini-grid system. The IC mini-grid system, which has been developed, it has 4 batteries, IC lead-acid batteries. It's connected for IC mini-grid system, which is Sunny Island inverter, and also we've got Sunny Boy inverter 1070, and also we've got the distribution box. How to connect those equipment together and test the power quality and test the performance of IC system. This is what I have done in this paper. We've connected the Sunny Island with the battery through the switching box, and the Sunny Island, it's integrated with the distribution box, which is G59. Also, we've connected the inverter, which is Sunny Boy 1700 with the distribution box and integrated together. We can connect the load through the local distribution network, as we will see in next. According to the manual of Sunny Island, which we've got, we have the Sunny Island inverter 6.0H inverter. This is Sunny Island. It can integrated with another source of energy, such as PV inverter, as you see in my slide. From the PV inverter, we can connect the local load as well. If we need to integrate it with the utility grid, we can integrate, but we need to provide a switching box to protect the network as well from injected high harmonic, or from disturbance, or from any external affected, which might cause a problem for the distribution network. As you see, this is the schematic of IC mini grid system, which has been developed. The switching box, it is used to protect the utility or the grid. The schematic diagram for switching box, it's quite complex, but we try in this paper to simplify it. It has actually 4 contactor. The contactor 3 and contactor 4, it's used for generate ground for devices when it's working in island mode. Also, we've got the contactor Q2, which is used for connected or disconnected the network, and the contactor Q1, which is used for protect system or PV system as well, which is connected. So this is the system. It is controlled by monitoring voltage and frequency devices, which is called blender control, which we've got in switching box. It is the model VMD 406. This is what we have got in my system, and this actually it's work perfect system when I test the power quality and test the response of IC mini grid system when it change the load. As you can see in previous slide, that is a switching box. It's needed to be integrated with other devices. So in this slide we will see that is Sunny Island inverter. The Sunny Island inverter, it has some connection which we need to connect it with a switching box. So it is given from the factory, that is how to connect every element, and also how to connect the battery storage and sensor for temperature, and also how to connect the remote control, which we can control the Sunny Island, because in this system the Sunny Island, it is like the processor for the control the IC mini grid system, and it give the all commands. So it is monitoring the grid as well, and when connected with switching box, and we can integrate other resource of energy, and we can integrate the battery, and we can supply the load with high power quality. We can the excess power we can store it in the battery, we can use it later. There are many advantages for this system. This is why I'm interested in this system. Let me now to explain that is how off a grid system and on a grid system integrated. Let's see the above diagram. This diagram, it has utility network, and we've got the PV panel which connected with PV inverter, and we can represent the house load or local load by resistive load, and also this is can integrated with the utility network. And we've got the bidirectional inverter, which we can deal with the battery storage. We've got also the battery storage below here, which connected through the bidirectional. So this system is kind of integrated together. This represents the IC mini-grid system, which I has been developed in the lab and working with it. This is called the IC mini-grid system, which work on off-grid and on-grid system. The IC mini-grid system which I have, it can work in two situations: off-grid and on-grid system. In on-grid system, it can work in 3 modes: backup system, autonomous mode, and island mode. These 3 operation for IC mini-grid system. The off-grid system, it's just sunny island and PV inverter and directly for the house without a grid. If we've got PV panel, it's produced so the energy we can use at house, the surplus power we can store it in through the IC mini-grid system to the battery, as you see in first slide. But during the night we can get the power from sunny island to the house. However, if PV is not enough to supply house, we can get power from the storage energy. This is basically the off-grid system. We've got connected the IC mini-grid system after it has been developed by realistic load, which is I used the resistive load in the lab, which represent a real load in real life, because we know that is many resistive load at house like lamp and fridge and other. Sometimes we can represent like resistive load, right? So I've tested the impact how to change the resistive load, because it's more flexible to change it. And I've tested when I change it through the switches, and I noticed that the voltage has a small impact, which is small interruption, but it's less than 1 period. However, the current, it has slightly changed, but we don't notice the change as you see in this slide. So this is a good system really. So I said, let's see we are interested in power quality of the current. So we need to test the power quality of the current. I come with the intelligent equipment and I tested the total harmonic distortion, and I found it is 0.64%, which comply with IEEE standard, which we need. So this is good system. And also I've tested the FFT analysis, and I found the harmonic is very less. And as you see here, it has been analyzed by oscilloscope and found it's very small really. So let's move now to see the other impact for IC mini-grid. We noticed that the system, IC mini-grid system, we've measured the voltage and current. We noticed that it's working at unity power factor, which good in operation. Also, but I found there's some limitation for this system. As you see here, we find that is the ripple current in DC side of battery, which might causes reduce the life of the battery. This is ripple, it need to be reduced. We don't like this ripple, it's very high, you know, it's twice frequency of the voltage and current, which might causes a huge current. If you see it's here in measurement in division, you will find 50 ampere division, which is high current. So in changing the current and ripple current might reduce the battery storage life. If it is a fuel cell, will reduce it. So this is the main core which we need to deal with it. I look for the internet and I found some reference. It is dealing with this problem. It used transformer with capacitor, transformer tab with capacitor. We can dealing with this problem. As well, we find that is some people using CLC filter for DC side, which we reduce this. We come for the final conclusion of my presentation and my paper. With comparing between the off-grid system and on-grid system. Also, we see how integrated the different renewable energy with the IC mini-grid system and how to dealing in the night. We've tackled the problem of intermittency for PV system as well. However, we find that there some challenges, such as the ripple current in battery side, which might reduce the battery life. Also, we find that the system it give a good power quality, and the power quality is improved, and this system also can integrate with other resources of energy. Not only this, we can also achieve the self-consumption backup system. The self-consumption, that is, we can set up the sunny island inverter that is dealing with summer and winter and the period, and we got more energy and more flexibility system. Thank you for my presentation, and if you got any question, please email me on my email here, alisert@yahoo.com. Thank you indeed.